Conduction is one of the primary modes of heat transfer. When considering conduction, there are two properties that are important to note. That is thermal conductivity and diffusivity. Let's see how these properties affect a simple conduction example. If we have a hot object and a cold object with a vacuum between them, we can insert a rod and heat will flow from the hot object to the cold object, and depending on the thermal conductivity, which is dependent on the type of material, heat will flow at a certain rate. So to develop an equation for thermal conduction, we include the thermal conductivity because depending on the material, heat will flow at different rates. Now if we make the rod larger, more heat will be transferred. And if we make the rod smaller, less heat will be transferred. So we include the cross-sectional area into the equation. Also, if we increase the length of the rod, less heat will be transferred. So we divide by the length because the larger the length becomes, the less heat transfer there is. We also multiply by the change in temperature because the larger difference in temperature will mean a greater amount of heat transfer. What does this mean for designing insulators and heat conductors or radiators? Insulators are thick to increase the length that the heat must travel. Also, materials are selected with a low thermal conductivity in order to slow down the rate of heat transfer. Now, when it comes to radiators, thin materials with high thermal conductivities are used. Also, fins are often added to increase the total surface area to increase the rate of heat transfer. Now, if we compare electrical conductors and insulators to heat conductors and insulators, we find that there's quite a difference. For example, copper is a conductor of heat and fiberglass is an insulator of heat. And if we compare these conductors and insulators, we find that there's a 10,000 times difference in the rate of heat conduction through copper than there is through fiberglass. Now this seems like a lot, but if we consider that between copper, an electrical conductor, and PVC, an electrical insulator, there's a 10 to the 24 times difference between the electrical insulator and the electrical conductor. What does this mean? It means that we don't have very good insulators compared to electrical insulators. For example, with a good electrical insulator, nearly all the electricity will travel through the conductor. However, even with the best heat insulators, some heat will always be lost. Now we can consider thermal diffusivity. Let's get some background on what happens when we insert the rod between the hot and the cold material to understand what thermal diffusivity is. If we have a rod between a hot and cold material, the temperature of the rod going from the hot side to the cold side will decrease linearly. However, if the rod is cold to start out and we insert it between the hot and cold material, this temperature profile does not develop immediately. First, the hot side will be heated, and yet the cold side will remain cold. Basically, the rod needs to be heated before heat can flow from the hot side to the cold side. And over time, a linear temperature profile will develop. Now, depending on the thermal diffusivity, this temperature profile will develop more quickly or less quickly. With a high thermal diffusivity, the linear temperature profile will develop quickly, but with a low thermal diffusivity, this temperature profile will develop slowly. Why is this important? If heat needs to be liberated quickly, that is, if something is heated quickly and for a short time, a high thermal diffusivity is needed to allow heat to escape. And thermal diffusivity is not only dependent on the conductivity, it's also dependent on the density and the heat capacity, because with a greater density or heat capacity, it will take longer for the rod to heat up, meaning it will take longer for the temperature profile to develop. However, once the temperature profile develops, we call this situation steady state, and thermal diffusivity is no longer important, only the conductivity and the geometry of the rod. So finally, to recap, we see that the amount of heat transferred is dependent on the type of material due to its conductivity, the amount of contact area between temperature gradients, and the length between them, and the value of the temperature gradient or the difference in temperature. Thermal diffusivity is an important property to take note of in different situations. However, in many situations it's not important because most materials will reach steady state fairly quickly and the thermal diffusivity is no longer important.